Hello everybody. This is calculus. This is 9G double integrals. Let's see what we have here. All right, for problems 1 and 2, find f of x. F double prime of x equals 2x. So that would be the second derivative is 2x. We want to find the function. If we know the second derivative and we want to find the function, we would have to find the antiderivative of 2x with respect to x. And then once we find that, we would have to find the antiderivative again. Okay, so if we're going from the second derivative to the function, we have to find the antiderivative twice. That doesn't sound too bad. Okay, the antiderivative of 2x, or 2x to the first, it's 2 over the new exponent, x to the new exponent. And remember, antiderivatives just go up by 1. So the new exponent is 2. Toss in a plus c for good measure. So we get x squared plus c. That's the first integral. Now, if we take the antiderivative of that, we will get the function. The antiderivative of x squared is 1 over the new exponent, 1 over 3, x to the third. The antiderivative of c, the antiderivative of any constant, like 2, the antiderivative of 2 with respect to x is 2x. The antiderivative of 3 with respect to x is 3x. So the antiderivative of some number c with respect to x is cx. Now we have to toss on a c for good measure. But we've already used the letter c, so let's just switch letters to d for good measure. And we've done it. Okay, that one was kind of fun. Let's check out the next one. Okay. Now, for problems 1 and 2, we want to find f of x. So here, once again, we know the second derivative. So we find the antiderivative of twice and we'll get the function. But what in the world is this mumbo jumbo? Let's not worry about it right now. We'll get to that shortly. Okay, let's take the antiderivative of 12x squared plus 6x minus 4. Okay, we can simply use the inverse power rule. There's nothing tricky here. So the antiderivative is 12 over the new exponent, 3, x to the third, plus 6 over the new exponent, x squared, minus the antiderivative of 4 is 4x. And let's toss on a plus c for good measure. Now, this would be the first derivative. Okay, now, if we look at this mumbo jumbo to the right, it says here the first derivative evaluated at 0 is negative 3. So if I put in 0 into the first derivative, I get negative 3. So I get negative 3 if I put in 0. By the way, 12 over 3 is 4. So if I put 0 in, I get negative 3. 6 over 2 is 3. 4 times 0. So if I put in 0, I get negative 3. Oh, that information helps me figure out what c is. This information lets me figure out c. I can do it now. I couldn't figure it out before, but if they tell me something like this, now I can figure it out. That's pretty satisfying. Okay, so what's c? All these zeros drop out, and c is negative 3. So now f prime of x, the first derivative, is 4x to the third plus 3x squared minus 4x minus 3. Now, if we take the antiderivative of that, we'll get the function. So the antiderivative of 4x to the third plus 3x squared minus 4x minus 3 with respect to x. So it's 4 over the new exponent, 4 over 4, x to the fourth, plus 3 over 3, x to the third, minus 4 over 2, x squared, minus 3x, plus c. 4 over 4 is 1, x to the fourth, plus 3 over 3, that's 1x to the third, minus 4 over 2 is 2x squared, minus 3x, plus c. That's f of x. Now, we are told that the function evaluated at 0 is 4. So this lets me figure out this second c. So if I plug in 0, I get 4. So I get 4 if I plug in 0. So 0 to the fourth plus 0 to the third minus 2 times 0 squared minus 3 times 0 plus c. All the zeros drop out, and c is 4. So my function then is x to the fourth plus x to the third minus 2x squared minus 3x. What I did was I just copied this down, and I'm adding my c, which is now 4. I've done it. It becomes more like a definite integral, so we don't have to try to figure out what c is now. It gave us enough information to figure out c. That certainly was exciting. We'll talk to you guys soon.